Hello all, this is Anita. Welcome to the machine learning video lecture series. In this video, we will learn how to find the information gain while drawing the decision tree. So let's get started. So here, why we need to calculate the entropy or the information gain. That is the very first question comes in front of you. So here you can see given a set of data like this and you want to draw the decision tree for this data set. So first thing we need to understand is how many attributes are there, what is the target class, whether it is a binary classification or multi-valued classification. So from this four attribute, which is the first attribute I should select as a root node, and once I select a particular attribute as a root node, what is the next attribute I should select as a next level node, and so on. So that is the first question we need to answer. So to give the answer of this question, we need to calculate the information gain of all the attributes. That is the information gain of weather, information gain of temperature, information gain of humidity, and so on. So once you calculate the information gain of every attribute, we can decide which is the attribute having the maximum information. And depending on that, we can select the attribute as a root node for the splitting purpose. So now let us understand what is information gain. So information gain is measure how much information a feature provide us about the class. Then amount of reduction in entropy after splitting the data node is termed as the information gain. So according to the value of information gain, we split the node and build the decision tree. Decision tree algorithm always try to maximize the value of the information gain, and the node having highest information gain is split first. So now let us see the formula of the information gain. So here gain of S of A is equal to entropy of S minus summation of V belongs to values of A, S of V divided by S, entropy of S of V. So here this entropy of S is nothing but the entropy of the root node. This value of A is the all possible values for the attribute A, and S of V is the subset of S for which attribute A has values V. So now let us understand how to calculate the information gain for this particular example. So here I have considered a simple decision tree having three features like F1, C1, C2, and here I have some for F1 feature I have 9 yes values and 5 no values. For C1 feature, after splitting this F1, 6 yes value and 2 no values, and at C2 we are getting 3 yes and 3 no values. So for these values we will see how to calculate the information gain and how we can select the root node for the splitting purpose. So here I have written the formula of the information gain, that is gain of S of F1. So here I am calculating the information gain of the F1 node. So that's why S of F1 is equal to H of S. So this is the entropy of the root node minus summation V belongs to the values S of V divided by S into H of S of V. So this is the formula of the information gain. Now here in the formula, first thing we need to calculate is the entropy of the root node. So that this is what the entropy of the root node, that is F1. So for this, I have written the formula of the entropy, which is the minus P plus. So here probability of the positive classes log of probability of the positive classes to the base 2 minus probability of the negative classes log of probability of negative classes to the base 2. So this is the formula of the entropy. Now here for this F1 node, so probability of positive classes is the 9 yes are there and total is the 14. So that's why here I have written minus 9 divided by 14 log 2 9 by 14 minus probability of the negative classes. So here 5 nodes are there. So that's why 5 by 14 log of 5 by 14 to the base 2. After calculating this, we are getting the value as a 0.94. So this is the probability, entropy of the root node. Now we need to calculate the entropy of the child node as well. So this is the C1 and C2. So we will calculate the entropy of the C1. So here again same, the probability of the positive, that is 6 divided by 8. So that's why minus 6 divided by 8 log of 6 by 8 to the base 2 minus probability of the negative classes. So here 2 nodes are there. So that's why 2 by 8 log of 2 by 8 to the base 2, and after calculating this we will getting 0.81 as the probability of the C1, entropy of the C1 node. Now we will calculate the entropy of the C2. So here similarly 3 yes and 3 no's are there. So you can see here this is the these are the values that we will be putting into the formula. So entropy of the C2 is equal to minus 3 by 6 log of 3 by 6 to the base 2 minus 3 by 6 log of 3 by 6 to the base 2. So here 3 yes and 3 no. So that's why 3 by 6 is there. And after calculating, we are getting the entropy of C2 as a 1. So now we simply putting this value into the information gain formula, that is in the equation number 1. So here you can see gain of S of F1 is equal to root node entropy, that is 0.94 minus S of V. So here that S of V is nothing but the remaining sample in our categories after split. So after splitting this F1, we are reaching at this C1, and after this remaining sample in our data set are the 8. So that's why 8 by 14, that is the total. So here S of V is the remaining one, that is 6 plus 2 is 8, and S means total sample. So that's why 14 into H of SV. So here H of SV is nothing but the entropy of this child node, that is the C1. So it is the 0.81 plus again the remaining sample node after splitting F1 here for C2, these are the 6 by 14 into entropy of the C2, which is equal to 1. So after calculating this, we are getting the gain of F1 is equal to 0.049. So this is the information gain of this F1 as a parent node. Now, similarly, we will calculate the entropy of the another node, that is the F2. And this is the sample value I have taken over here. So after calculating the information gain of the F2, we are getting the value as 0.059. So this is the sample one I have considered for understanding the example. Now, take a pause here and tell me which feature to select, F1 or F2 for the splitting purpose. So after done, resume the video. So here F1 and F2 feature we want to select for the splitting purpose, or we want to select as a root node. So for that purpose, we are calculating the information gain of F1 and F2, and the feature which is giving the more information gain, that feature we will be selecting as a root node for the splitting purpose. Here gain of F1 is 0.049 and gain of F2 is 0.059. Here gain of F2 is more than F1, so that's why we will be selecting F2 for the splitting purpose. Now the next question comes in our mind is when to stop the splitting. So when tree reaches 100% purity, which indicate that each child or subset node has a homogeneous or a single class. Then node is pure when all classes are yes or no. This might cause an overfitting issue. So the splitting criteria is very important in case of decision tree. A few strategies to overcome the overfitting issue is through the hyperparameter tuning. So you can use the parameter like maximum depth, minimum sample split parameter while drawing the decision tree. Then you can use the pruning technique like post pruning and pre pruning, then gain ratio or the statistical significant test, that is the chi-square test. So these all are the technique to overcome the overfitting issues. So this is all about the information gain. Thank you.